A site facing a $17 billion cleanup has just been promised a future worth more than $100 billion. In western Kentucky, a former uranium enrichment plant is being recast as one of America's largest artificial intelligence campuses. The plan combines server buildings, a new natural gas power plant, enormous battery systems, and upgrades to the electric grid. If everything moves forward, construction could employ about 8,000 people. 600 permanent jobs are projected to follow, but none of those buildings exists yet. The power agreement still needs approval from Kentucky regulators. The project still depends on final negotiations and definitive documents. And the public announcement did not name the companies that would ultimately fill the campus with computing equipment. So this is not yet a story about a finished technology hub. It is a story about why America is placing one of its biggest AI bets on land still being cleaned up from the nuclear age. The site sits outside Paducah, near the Ohio River, on roughly 3,500 acres of federally owned land. For most of its life, this was not a technology campus. It was the Paducah Gaseous Diffusion Plant. Construction began during the early Cold War, and the plant started operating in 1952. Its first purpose was to enrich uranium for the nation's nuclear weapons program. Later, it produced enriched uranium for commercial nuclear power plants. The process demanded extraordinary amounts of electricity. Inside vast buildings, thousands of machines pushed uranium gas through barriers, slowly increasing the concentration needed for fuel. That industrial history matters now. Paducah already has land, roads, water access, fiber connectivity, and links to high-voltage transmission. The same basic qualities that once made the site useful for uranium enrichment now make it attractive for another electricity-hungry industry. Commercial enrichment ended in 2013, but shutting down production did not end the federal government's responsibility. More than 5 decades of work produced radioactive, hazardous, and mixed waste. Contamination was found in soil, surface water, sediment, and groundwater, both on the property and beyond its boundary. The Environmental Protection Agency placed the plant on the Superfund National Priorities List in 1994. Among the contaminants are uranium, technetium-99, polychlorinated biphenyls, and trichloroethylene, an industrial solvent commonly called TCE. The former C400 cleaning building became a major source of the site's TCE groundwater plume. Federal crews have spent years treating groundwater, removing contaminated material, monitoring wells, and preparing old process buildings for demolition. The Energy Department currently estimates that the full cleanup will continue until 2065 and cost about $17 billion. That does not mean every acre is equally contaminated, or that redevelopment must wait until the entire cleanup is finished. The site's fenced former plant area occupies only part of the federal property. Regulators use investigations, land controls, monitoring, and separate cleanup zones to determine where work can happen. The EPA says current human exposure is under control. It also says groundwater migration is not yet fully under control and that the site as a whole is not ready for unrestricted use. Those facts can exist together. Portions of the property may be reused while environmental work continues elsewhere. In fact, the Energy Department has made that parallel approach part of its strategy: restore contaminated land, reduce the federal footprint, and return suitable areas to productive use. The proposed AI campus is the largest test of that idea Paducah has ever seen. It would not erase the cleanup mission, it would be built beside it. In November 2025, the Energy Department invited private companies to propose AI data centers and new energy projects at Paducah. The government offered access to federal land, but applicants were expected to finance, build, operate, and eventually decommission their own projects. They also had to show financial viability and a path through permitting and utility interconnection. On July 29, 2026, the department announced its selected partnership. Brookfield was chosen to develop and operate the data center campus. NextEra Energy was chosen to build and own the dedicated power infrastructure. Big River's Electric Power Corporation would provide wholesale electricity. Jackson Purchase Energy Cooperative would handle retail service. Paducah Power System would participate as a community partner. Together, the coalition described a privately funded investment of more than $100 billion. That number transformed a regional redevelopment story into a national headline. At full scale, the campus is planned for up to 1.8 gigawatts of utility capacity and more than 1.2 gigawatts of computing load. Those are not interchangeable numbers. Utility capacity describes the scale of electric service available to the campus. Compute load is the electricity expected to reach the servers and supporting systems. Brookfield is expected to lease roughly 600 acres for the data center development. The first components could begin operating as early as 2028, with full development targeted around 2031 or 2032. The public schedule is aggressive because the site does not begin as empty farmland. Roads, transmission, water infrastructure, fiber, and an experienced industrial workforce are already nearby. But the advantage is not simply that Paducah has power. The project is designed around the idea that the campus must bring new power with it. NextEra plans to build up to 2 gigawatts of new natural gas generation at or near the campus. It also plans transmission upgrades and as much as 2.6 gigawatts of battery storage. The gas plant would produce energy. The batteries would store energy and help manage when it enters the grid. Together, those resources are meant to grow in stages as the computing campus expands. The coalition says the new supply would exceed the campus's own requirements, allowing excess electricity to move onto the regional grid. This is central to the sales pitch. Across the United States, communities are asking whether data centers will raise power bills, consume limited grid capacity, or force utilities to build expensive infrastructure for a small number of enormous customers. Paducah's answer is a bring-your-own-power model, new generation built specifically for the new load, with project costs intended to stay off existing household and small business bills. But an intention is not the same thing as a tested result. The power service agreement between the local utilities still requires approval from the Kentucky Public Service Commission. The wider project also remains subject to negotiation and definitive documentation. Those steps will decide obligations, schedules, protections, and what happens if demand arrives later than expected. There is another unanswered question: who will use all that computing capacity? The announcement named the developers, power companies, and utility partners. It did not publicly identify a hyperscale customer or disclose how much of the future load is already contracted. That does not mean customers do not exist. It means the public cannot yet measure the distance between announced capacity and committed demand. For a project built around a $100 billion headline, that distance matters. The same is true of the economic promise. 8,000 construction jobs would reshape the regional labor market for years. 600 permanent positions would be significant for Western Kentucky. But the ratio also reveals the nature of modern AI infrastructure. Enormous capital spending does not necessarily create an equally enormous permanent workforce. Kentucky Governor Andy Beshear said his office had not been briefed before the announcement and raised questions about power, environmental effects, jobs, and whether the community would receive a fair share of tax revenue. Those are not arguments that the project must fail. They are the questions any community should ask before an announcement becomes an agreement. Who pays for the infrastructure? What tax incentives apply? How are water and noise managed? What happens if part of the campus is delayed? And can the cleanup continue without being weakened or obscured by the new development? Project officials say the campus would use closed-loop cooling, recirculating water rather than continuously consuming it in a once-through system. A fact sheet provided at the announcement estimated that the data center and gas facility together would draw less than 5 million gallons per day from the Ohio River. That is a concrete claim regulators and the public will be able to test against future permit applications and operating data. It also explains another reason Paducah was selected. This is already a heavily engineered landscape. It was designed around large buildings, industrial water, high-voltage electricity, security, transportation, and a workforce accustomed to regulated facilities. Building on such a site can reduce pressure to convert untouched land, but it also requires unusually careful boundaries between redevelopment and remediation. The attraction and the risk come from the same history. Paducah is not an isolated experiment. The Energy Department is trying to turn several former federal nuclear sites into what it calls American energy hubs. A related AI and power project was announced at the former Portsmouth enrichment site in Ohio. The logic is straightforward. AI companies need land, power, water, fiber, and speed. Former federal industrial sites may already have much of the physical foundation. Private investment can put selected land back into use while federal cleanup continues. But this model also transfers a national argument into specific communities. How much new fossil generation should be built for AI? How should ratepayers be protected? How much public oversight is needed when projects move quickly? And what counts as success? The size of an announced investment or the amount of useful infrastructure that actually reaches operation? Paducah will become one of the clearest places to watch those questions unfold. The next milestones will be less dramatic than the $100 billion headline, but far more important. First, the parties need final agreements. Then, the power service arrangement must survive regulatory review. Developers will need permits, financing commitments, interconnection plans, and identifiable customers. Construction must begin without disrupting the cleanup work. New generation and transmission must arrive before the servers demand them. And over time, the promises can be measured. Electricity rates, tax revenue, water use, construction jobs, permanent employment, and the progress of environmental remediation. If those pieces align, Paducah could become a model for reusing America's most complicated industrial sites. If they do not, the announcement will remain larger than the development itself. For 70 years, this land has reflected what the United States considered strategically important. First, it was enriched uranium. Then, it was the long work of cleaning up what that era left behind. Now, the proposed future is artificial intelligence. The machines are different, but the underlying demand is familiar. Extraordinary amounts of energy, industrial-scale infrastructure, federal involvement, and a community asked to carry national ambition on local ground. Paducah has been promised more than $100 billion, thousands of jobs, and a place in America's AI build-out. The real story begins after the announcement. Not when the number is repeated, but when contracts are signed, power plants are permitted, servers arrive, and the cleanup continues. Only then will Paducah show whether a site shaped by the nuclear age can truly become infrastructure for the age of AI.